Hi everyone. So let me start this video by first introducing myself. This is Ashnath Kothari here. I am a qualified associate actuary. I have cleared 14 actuarial exams out of the possible 15 and have cleared all of these in the first attempt. I have also secured All India rank in two papers, CT6 and SP5. I have been teaching for more than 7 years now. Started when I was second year in my college. On the professional work front, corporate side, I have experience of working in PNC insurance sector. I had previously worked with AXA XL. I'm a graduate in economic honors, and I also was the BSc department topper in my college from Calcutta University. So that was a brief introduction for ones who are watching our video for the first time. So in this particular video, we are going to be discussing the tentative solutions for CM1 Paper A, which had come in IFoA April 2023 session. Now, before we get started, discussion of the paper, let me just inform all of you that the new live batches for IFoA September 2023 and IA November 2023 session is starting from May 7. Admissions are open for it. Do keep in mind, we just have one single batch for each term, for each exam. Classes will be available in live online mode, in live offline. Currently, our offline center is in Kolkata and in pre-recorded mode as well. All the students who join us do get a chance, or rather do get access, complete access to all the pre-recorded content. And along with that, they have the option to attend the live classes, either in offline or online form, whichever is convenient for them, as per their availability. We would be creating study groups wherein we share the weekly tasks to ensure that all students, be it ones who are currently studying in the college, be it ones who are working, have something of a target, so that they can plan their studies accordingly and they always have the constant push, or let's say external motivation to be regular with their preparation. Now, as for the mode of our classes, most of our live classes would be on the weekends. That will ensure that students, whether working, not working in college, can attend the live classes and the timings does not clash. There would be certain live classes on weekdays as well, primarily in the initial stages to ensure that preparation, that syllabus is being covered at a good pace. We intend to complete the syllabus from our part around first week of May itself. So basically from 7th May to 7th August is what we are targeting right now. Now, the focus of the live classes is basically to ensure that the students studying for a particular paper in a particular batch have all the adequate concepts. It could be that we are teaching primarily in a particular session for a paper A concepts. It could be paper B concepts. It could be question solving, doubt clearing. Point is, wherever the students who are studying from us in a particular session are facing issues in, the live classes would be, focusing on them so that these concerns or these doubts queries are resolved and we can make sure that a student has a pretty good learning experience, not just from exam clearing point of view but also from the point of view of being able to understand the concepts and the ability to apply them in the ever changing real world scenarios. We always motivate students, or we always push students to start early. I personally feel that starting early is one of the most underrated things in the eyes of others, but something which is extremely impactful. To promote that, we are having attractive early bird offers for ones who are enrolling for the classes by April end. These are customized on an individual basis depending on which papers they have cleared, which papers they are planning to give. So, in case you're planning to start your preparation under our guidance, do join us today for a meaningful, impactful, and wonderful learning experience. CM2 paper of this session was again, similar. The difficulty level was similar to the past sessions. It was a slightly different paper in the sense there was a higher proportion of, let's say, wordy based questions, or, a comments based question as compared to the previous years. Some of the students were caught off guard with respect to the more proportion of, let's say, theoretical questions in paper A. So in this particular video, we shall be discussing the numerical solutions of CM2 paper A. Do keep in mind that in case you observe any sort of errors, be it with respect to calculation or any other steps, do let us know through the comments section. We would take a look at them. In case any errors have been found, we would be pushing in the rectifications as well. So we would be sending those to the comments section and pin that particular comment. So the ones who are watching this video, please parallelly do take a look at the comments section as well to see whether any rectifications have been pushed or not. Also, do subscribe to our channel so that you are updated with the release of paper B whenever that is in the near future, as well as all other educational content which we might upload going forward. Also, don't forget to like this video in case you find this video helpful. So now let's get started. The first question. So we'll quickly glance through the solution. We have a logarithmic utility function. We find the first derivative, second derivative, follow up with calculation of EW, and finally RW. We need to show it as isoelastic. So we see that the first derivative of RW is nothing but 0. And therefore, the utility function must be isoelastic in nature. This is part 2, expected loss. Part 3, there would be another term. It's not being fit in this particular image, which is nothing but 0.949 into ln of, 1500 thousands, or rather you will say 15 lakh or 1.5 million, depending on whichever units you need to work. And we're getting it to be as 18,138. So this was the first question. Next numerical question which we have over here is question number 4. Here question 2 and 3 were slightly different, and some of the students were, taken aback with these sort of questions, specifically question 2. The ones who have done their institute material well might be in a position to, make meaningful inferences. Other than that, those who tend to skip material, even if they start very early with the preparation, they would have struggled because it's a very different type of question than what has usually been asked in the past examinations of IFoA. So next what we have is question number 4. Let's quickly take a look at the solution for that. The distribution of ln S5 is nothing but 5 mu plus log 100, and the variance parameter is nothing but 5 sigma square. Then this is part 2. On solving, we're getting the values of mu and sigma as these. And then third part is nothing but computation of probability that S10 is greater than 100. This is coming out to be 0.398512. Next, what we have is question number 5. Now, do note in mind this question 5 has been directly taken from past year examination. So let me just check that. I had noted the year from which this was taken. It was a IFoA past year question as well. So this is nothing but IFoA Paper CT8 of session April 2010, question 7. The ones who have access to revision notes, they would have seen that question there itself, and it's available in the past year paper. Exact same questions, same numericals, only little bit differences. If I recall correctly, is there. There in DT, they had written this to be nothing but simply BT itself. Over here, they have written it as B probability minus CT. So apart from that, everything remains same. This is also same only, just that instead of representing in one way, they have chosen to represent in some other way. So ideally, students should have scored very well in this particular question. This is where, practice in the past year questions becomes very important. Even let's say you do not understand how to solve this question or why the way you have solved it. Point is, if anything similar comes, you all should be in a position to replicate that, because these are the ones where you need to score and, score high quantum of marks. So this is question number 5. I express ST over here. Then I'm calculating DST. Similarly, I do that with DT, where I find DDT. Now, these are nothing but under equivalent martingale measure, or alternatively known as risk neutral measure. There, the drift coefficient must be same for all tradable assets. At the same time, the drift coefficient must be nothing but equal to the risk-free rate. Using these two properties, we compute the value of C, and finally, we conclude the value of R. Some of them did struggle in this question. I mean, the ones who were, looking at materials past year questions could recall they were in a position to, solve this question completely, because you readily have a solution for this question available. Next, question number 6. This was on a question which was on the easier part. So let's quickly glance at the solution. We have 2.2, we have variance as 56 by 75. Then for asset B, it's 2.2 mean, variance is 4. We will be preferring A because both of them have the same mean, but asset A has a lower variance. We have a quadratic utility function. So determination is only using the first two expectations, that is, let's say, mean and the variance. Part 3, we need to compute these respective probabilities. We are getting here. So this was question number 6. Next, moving forward to question number 7. Also, specifically, I'm repeating again this in this video. I had solved this paper just day before yesterday itself, post conducting of exam. So I haven't spent much time in cross-checking my solutions with anyone because I haven't been able to interact with students so far. Wanted to release this video as soon as possible so that my set of work is also done for this session along with the completion of all exams. So please, do let us know through comment section in case you observe any sort of calculation errors, which I feel personally slightly there might be higher chances for this particular solution because I haven't been able to cross check any of my workings so far. Next question 7, we have this PDF. First, we find expectation. It's coming out to be 4 by 3. Now we use the formula of semivariance and we compute it. And it's coming out to be 1.0625. Moving forward to part 2, we need to find the VAR. I'm getting 95% VAR as 1.0129. Now I'll suggest to express this in words. Originally, the concept of VAR was always through profit and loss, but of late in the last, I'll say 2 years or so, the way the IFO is giving questions, they are talking about the whole portfolio amount. So the way to express this in words is there is less than 5% chances of the total portfolio value being less than 1.0129 over the particular time period. That's the way to present. Other than that, the way it's described in material, if you'll take a look at the past questions before 2020 or so, you will find most of them it's related to profit or loss. That's the underlying way in which VAR has been defined. But here it's kind of the total portfolio amount and not just, let's say, profit or loss, which is being looked at. It's consistent. It's just the way how you communicate the results. This is part B. I'm getting it to be 1.0267. Next, question number 8, run of triangles. Fairly straightforward. So these are the calculations I have got. Now, if I need to add all of them for all the accident years, it's coming out to be 5364.27. And if I just need to, let's say, put in the answers in the form of the ones which we are estimating, then it's coming out to be 1949.27. The same answer would have come had the triangle for paid claims would have been there. So again, depending, you can, give both of the answers. This could be assuming the claims are completely incurred, you're finding the outstanding claims reserve. And if you need to, let's say, if you're trying to infer outstanding claims as those claims which have not been reported, so the ones basically which we need to kind of, estimate, in that case, it's coming out to be 1949.27, which is equivalent to had the data been paid itself. Finally, moving to question 9. First part, we need to show that the market portfolio has a beta of 1, which is a trivial question sort of. Next, part 2 and 3, let me quickly take you all through that. This is P 0.3 R1 plus 0.7 R3. Expectation of P is coming out to be 7.45%. Then this is the variance. In part 3, I have computed EM, VM, and therefore I'll get sigma M, and then I can calculate the market price of the risk. Or before that, I'll find the risk-free rate. It's coming out to be 4.271%, and the market price of risk is coming out to be 0.66. So hope that you all did find this particular video useful. Thanks everyone.